Hypothesis test example. So the urinary fluoride concentration, parts per million, was measured for a sample of livestock grazing in an area previously exposed to fluoride pollution. And the measurements are provided. So you have this 25.8, 36.6, 26.3, 21.8, 27.2. Does the data indicate strongly that the true average fluoride concentration for these livestock grazing in this polluted region exceeds 25? And we're going to test at the 5% level of significance using the t-test. So the first thing we're going to do is start setting up our null and alternative here and get our test statistic in play so that we can get an idea of how far away our data value average is from our testing average, our 25. So we'll set this up. We have our H null, and we're testing if the mean is either equal to 25 for the null, or for the alternative, exceeds, going to be greater than, so greater than 25. So this is what they would call a one-tailed test, since you're just being greater than this 25. So in order to test that, we're going to use this test statistic t, and the test statistic is x bar minus mu naught all over s divided by the square root of n. And in this case, the x bar is just your sample mean. Using technology, I calculated that to be 27.54. The sample standard deviation, again, I just used technology to get this, and I got 5.47. And then the mu naught in this case is going to be 25. That always comes from your hypotheses. And then the n is equal to 5. And when you plug all those values in and find your test statistic, what you end up with is going to be 1.038. So really what this is telling me is that in some hypothetical normal distribution, I'll try to draw that a little better there. Some hypothetical normal distribution, we are over here. The mean in the middle is associated with 0 on the standard normal. We're basically one standard deviation on the positive side. And we want to know the area greater than this. And the reason we want to know the area greater is because of our alternative hypothesis, the probability that exceeds it. So when you look at t-distribution, there's different ways to do it. You can do this with technology, and with technology, you'd probably just plug this information in, and it would give you a probability value that you would test against that 5%. And what you're looking for here is something, a percentage smaller than 5%. If you're less than that level of significance, then that means that there is such a small chance that your sample would come from something with a true value of 25 that it must be greater than 25. So here, with 1.38 standard deviations away, I can tell you that the t, it's not going to be big enough. For this 5%, we're going to need a bigger t value. We're going to have less area in this tail. But we can verify that using a t-distribution table. So when you look at this table, there's a lot going on in here, but we're looking at a one tail. And a degree of freedom here would be 5 minus 1, or 4. So I'm looking at that in the left column, I'm looking for the 4. So just, 4 lines down basically. And then I'm going inside the table and looking for that 1.038. And really I don't have that. I have a 0.941 and a 1.190. So my value is somewhere in between there. And for the one tail, looking up top, that tells me I'm somewhere between 0.20 and 0.15. And that really means then that I'm somewhere between 15 and 20%. So the area then, going back to what we were looking at before, our area here is approximately between 15% and 20%, or this 0.15 to 0.20. And that is not small enough to indicate that we have an alternative scenario where we're actually greater than 25. And in order to do that, again, we really need to have, with the 5% level, we would need to see this percentage here be smaller than 5%. So, if your test value is small, you reject the null, is kind of the idea. And we're not small here. We are pretty big, compared to 5%. So in this case, the data does not strongly indicate that the true mean is greater than 25. Even though we got a 27 for our average, it's not far enough away to say, oh yeah, for sure, if we were to do a bunch of other samples, there's a really good chance that we're going to be over 25. This is just one sample, and based on that one sample, it's not far enough away from 25 to say that we're going to be more than 25. And again, that test statistic here would be, it'd be closer to 2, maybe over 2, in order to get into this, 15 to 20%. In fact, if we look at this table here for the one tail, and the degrees of freedom of 4, we would really want to be looking at something, a t statistic, test statistic value, bigger than that 2.132 value that you see there in that fourth row of values. So, and looking up above at the one tail, the 0.05, that's where you would have that 5%. So in order to be less than 5% going to the right, where you see the smaller values up top there, you would want to be bigger than 2.132 for that test value, more than 2 standard deviations away, essentially, on your little normal distribution that the t is related to. So I hope that helps with that problem, and thank you for watching.